I'll be differentiating those with left-handed family background, which I'll define presently, from those that do not have or do not report left-handers in their background. I'll briefly discuss at the end some implications of the differences in the behavioral and neurological organization for language, the implications of those differences for language universals. We can now frame the question this way: is there one normal neurological substrate for language and cognition? I think a lot of research for the past 100 years or more has assumed that there is, and that there are the abnormal ones that I mentioned that are very specific, with specific syndromes. But in general, I think the fields have assumed that there's something there that's constant and normal. As I said, I'll be looking at the effect of familial handedness to show you that there in fact may well be at least two normal neurological substrates, which of course implies that there may be many more. It starts with a observation, rather detailed observation by Rooryck, first published in his, I think, 1948 book on aphasia. That was in Russian and then later translated. And what he noticed is that his patients, kindly provided by the German army, recovered faster from left hemisphere damaged aphasia if they reported familial left-handedness. These are right-handed patients. They also showed a higher frequency of crossed aphasia, both of which implies that there are some aspects of language that were organized in the right hemisphere. Now, as I'm going to emphasize, we're not talking about a tiny little group of people. We're talking about almost half of the right-handers in the world, or at least in the American surveys that we've done, are right-handers with familial left-handedness, looking at the envelope that consists of parents, siblings, grandparents, aunts, and uncles. So it's not a small group. Now, there's something that at the outset I need to remind you of, or inform you of. As you fade in and out listening to me, you may wake up at some point, at least that's how I unfortunately attend lectures, and think that I must be talking about left-handers. I'm not. Every subject here that I'll discuss is right-handed. And I'll say it again, and maybe put it again. and just to put it in a different form to nail it down, so please remember this. Believe me, I've learned from experience how necessary it is to have that slide. Okay, so we'll start with many years of research where we were really primarily interested in trying to study psycholinguistic variables or linguistic variables in the experimental setting to try to develop a model of language processing. That was our primary goal. But for accidental reasons, when I noticed that an important subject variable that created a lot of noise in our data if we didn't control for it was not only whether the subject was right or left-handed, but in fact whether the subject had familial left-handedness. And so I started tracking it many years ago with all of the studies that we do and have done. Where, as I say, the studies were not themselves directed at trying, most of them were not directed at trying to understand the basis for the difference between these two groups of people, but simply we tracked it and then could sometimes use it as a covariate in our analysis. But the generalization that gradually emerged from, I would say somewhere like 20 to 25 different kinds of experimental paradigms, looking both at acquisition and also adult processing of language. The generalization that seems to characterize the behavioral difference is that FS plus people, that's people with familial sinistrality, seem to be more sensitive in immediate processing to lexical access, lexical recognition, word production, things that have to do with individual words, and less sensitive in the immediate sense to syntactic patterns. Now, when we understand a sentence, we have to not only recognize the words, we have to organize them compositionally according to the syntactic pattern. So everybody gets there. But when you do these experiments where you're looking at reaction time in some fine-grained way, a matter of differences in milliseconds can be revealing. That's the kind of study that we do. And I'll give you an example. Sample experiment where we actually were directing our attention to the difference between FS plus and FS minus subjects. We show that a word probe, where you have to recognize whether a word was in a sentence you just heard, is faster with FS plus, but a phrase probe is slower with FS plus. And here's the paradigm. Subjects hear a bit of a sentence, then a warning tone, then there's a pause, then there's a probe word, and they have to respond whether the probe word was in the sequence that they just heard. And sometimes it was, and sometimes it wasn't. And the probe could either be a word or a phrase that bears some relation to the word. So the paradigm, I don't have an instance of the trial, so I'll just imitate it. So a trial goes something like this. John was careful to call everybody in the class up yesterday and beep, up. Okay, so that's what a subject would hear, or would hear the phrase talk on phone. And they know ahead of time whether it's going to be a phrase probe or a word probe. And these are the results. This is from a study we published a decade ago. The FS plus people are faster to correctly recognize the word, but they are slower to correctly recognize that the phrase was basically related in meaning to the something in the fragment that they heard. So a generalization that was supported by other studies as well is that FS plus people seem, as they understand sentences, to be constructing an inventory of the words, or at least in certain kinds of experiments where constructing an inventory would be a good idea. Whereas FS minus people seem immediately to grasp aspects of the meaning initially. So Luria's FS plus patients may have looked as though they're recovering faster from aphasia because they're basically utilizing their lexical knowledge, which of course in Russian, where so much is dependent in fact on particular inflections, it might in some sense of the word simulate recovery of syntax. That's just a speculation on my part, but Luria was a very clever fellow and did a lot of interesting stuff, but he didn't have some of the psycholinguistic tools that we have today. But this could make a prediction that if what's at issue is that the lexicon is relatively available in the right hemisphere and perhaps the left hemisphere, which is perhaps a reason why word access is more efficient, that makes a prediction that word probe type tasks would show a greater right hemisphere activation in FS plus. So we reran recently the experiment, the same experiment, just with the word probe data at the moment, but now we were collecting evoked responses, EEGs, and this is a compositional picture of the P200 response. This is for FS plus, where you can see what, of course we don't exactly know the source of this, but prima facie, this looks like the right hemisphere is relatively activated compared with the FS minus, which has a little blip over here at any rate. And the dots represent where in a mixed effects model there are reliable statistical differences. So that's an initial confirmation of the kind of prediction we're making. But of course, at this point, in these kinds of data, we are categorically differentiating FS plus and FS minus, which is a pretty blunt instrument, a blunt categorization. You either do have a familiar left-hander somewhere in your background, or you don't. But there's every reason to believe, given the failure of monogenetic single gene models to adequately predict left-handedness, there's reason to believe that the genetic basis for sinistrality is probably graded as more than one gene, and as I alluded to earlier, in today's thinking, probably also a maturational process, and therefore, in that sense, epigenetic as well. So it's going to be more subtly graded than simply you got it or you don't. And so what we've done is to construct a genetic load model, a model of the genetic load for left-handedness, which we then can correlate with various behavioral and neurological measures. And the way a model works is this. This is a family handedness pedigree that we have subjects fill out. We've got, actually, at this point, about 4,000 of these, which means we actually have full data for 4,000, and we have, of course, partial data for everybody else that's been reported on. So we actually have some data on about 40,000 people. And we take that, and with the relatively standard model, iteratively converge on the best constants to predict the likelihood from the particular array that a subject shows in this, to predict the probability distribution that person either is left-handed or would have been left-handed. And then we test it, of course, including the population of both right and left-handers, so we can verify the accuracy of the model. This is primarily the work of a very bright graduate student, Roland Hancock, who's been working with me on this. And so, I'm sorry, so we now have this model. We can take the subject, have the subject fill out a pedigree, and then assign the subject a probable central tendency for the genetic load that that person would have been left-handed. I remind you again, all the subjects are in fact phenotypically right-handed, strongly so. We only cull the population to make sure the right-handedness is itself always strong. So now I'll present two studies that were done together in collaboration with Daniela Samler, Roland Hancock, and Angela Frederici, probing for the effect of genetic load on certain aspects of the neurological response to anomalies in language and in music. So we start with the classic phenomenon, so-called ELAN, early left anterior negativity, which is a negative bump that occurs when an anomalous word is thrown into the middle of a sentence, contrasting the trumpet was blown versus the trumpet was at the blown. And I'll play you some examples. But the characteristic finding in a number of laboratories, starting actually at the University of Arizona many years ago, is that there's a sharp left anterior negative blip at the point of the anomalous word. Here's some sentences that we use. Just a minute, I hope you can hear it.
Die Maus wurde gefangen.
Can you hear that?
Ja.
Okay, so that's a correct sentence.
Der Fußball wurde vorn gefangen.
That's a sentence with this extra unnecessary word here. And then what the subjects think they're doing is they think that they're listening to see if there was a voice change in what was presented.
Die Torte wurde gebacken.
Okay, so they're not asked to pay attention to anything that's anomalous. They think their task is a really dumb one, namely to press a button after the sentence if there was a voice change during the sentence. And this is a depiction of the results we get. The major finding that was a surprise at first, this study had never been done before, differentiating FS plus and FS minus subjects carefully. They're also balanced for gender, of course. The main finding was that the amplitude overall, especially anterior, the negative response was much larger in the FS plus and the FS minus people. Here's a depiction of that. The red dots are the negative amplitude for FS minus, the blue for FS plus, and it doesn't take more than visual inspection to see the difference. But most interestingly, we can now correlate the genetic load for being left-handed against the strength of the negative response. And we get a very intriguing and promising correlation. The more likely you were, remember these are right-handers, but the more likely you were to have been left-handed according to the genetic load model, the stronger the negativity of your overall response. Why might this be? Well, if it's the case that FS plus are in fact, wherever in the brain it happens, glomming onto words quickly, the nature of this kind of anomalous language is really that you're listening to a sentence and then suddenly a strange word pops in there. It's often been characterized as a study of phrase building, but I think that's overstating the case. I think it's a study of what you have to do to ignore an intrusive word. If it's the case that FS plus people are really focusing in processing on initial analysis of words, then this extraneous word is going to cause a much bigger effort to ignore it. And so that's our interpretation of this result. Now there is a weak confirmation of the early left negativity across all subjects. It is the case that the left negativity is weaker in the FS plus than in the FS minus. So there is a tendency for the left negativity to be more pronounced in FS minus than in FS plus, although it overall exists in both. So now I turn to the music, a corresponding study of music, and what had been found before by various groups at the Planck in Leipzig, and then other researchers, is an early right anterior, which this is for non-musicians, I should point out, that goes with the usual story that claims that music is more dominant in the right hemisphere than the left, thereby hangs a very long tail, but at least for musically unsophisticated people that may be true. One of the things about the ERAN, the early right anterior negativity, is that there's been much more variability in the literature as to whether it really exists or not. In discussing this with the people at the Planck, we decided to look into the question of whether the variability that occurs is really because previous experiments haven't controlled for familial sinistrality. And so we did that. And so here, in this case, you're listening to harmonic sequences, and occasionally there's an odd one. Again, here, you think that what you're listening for is a change in instrumentation, not a strange harmonic sequence. Okay, that's a nice, boring harmonic sequence. Okay, now that's not dissonant, but there's something odd about that last chord. And finally, what the subjects think they're listening for is this. A shift in, at some point in what the instruments actually are. And so this is in some sense analogous to the kind of studies that have been done with the intrusive word or the anomalous word in language. So here's an initial picture of the relative response to the irregular chord. using the regular chord as the control, of course. Here's the overall picture of whether there's more early negativity on the right or the left. And what you can already visually see that, so overall there's a weak confirmation of the right negativity, but it's pretty clear that this is primarily because of the right tendency of FS plus people. And so whereas the FS minus people are balanced, or even slightly probably just balanced. And again, we can correlate this with the genetic load, and now we again find that, although the data is kind of scattered, there is a correlation in there, that the more likely that you would have been left-handed, according to the genetic load model, the more there is an early right negativity. So we have an initial confirmation of the genetic load model correlating with a measure of the effect of an anomalous word, and also correlating the other way with the effect of an anomalous chord. Now, there's an interesting thing that popped out of this, which I'm going to show you, although I can't claim to fully understand it yet, but I think it's really intriguing, and we, of course, are running more subjects and definitely will be pursuing it. And that's the question about the relationship within any given subject between the extent to which that subject shows a left negativity, an early left negativity to language, and an early right negativity to music, to the anomaly in music. But I should have mentioned, all subjects were run in both studies in a counterbalanced way. So we have music data and language data from every subject. And this is the way the correlation looks. So what this is showing, tending to show, of course it will require more work, but it's pretty striking as it is. What it's showing is that for FS plus people, insofar as an individual shows a right hemisphere effect for music, that subject shows a correspondingly relatively stronger left hemisphere effect for language, suggesting that there's a continuum of differentiation, a functional differentiation of how the two kinds of processes involved for FS plus, but as you can see for FS minus, at least so far, no such correlation exists. And this is with the anterior, looking at the anterior areas only. There's no effect at all for posterior areas. So I just mentioned this because I think that it's pointing at, it's telling us something that I think is going to be very important. So to summarize this segment, we looked at the response to an anomalous word in a sentence and find a smaller early left negativity in FS plus, but a much larger overall negative response in FS plus, and that fact co-varies, in fact, with the genetic load for being left-handed. In the case of music, we found a larger early right negativity for FS plus. This is all with around N200. And in that case, the early right anterior activity co-varies with the genetic load for being left-handed. Remember, it's always right-handers. And finally, the last point, which we're just beginning to probe, is the relationship between the extent to which a subject shows a left negativity for language in relation to a right negativity for music, showing that the more strongly the left anterior negativity is for language, it's also more strong, relatively speaking, for the right anterior negativity for music, but only in FS plus subjects, suggesting a greater differentiation of kinds of processes, or at least modalities of processes, in FS plus subjects. So this brings us back, in conclusion, to the earlier question that's been driving some of this. The lore is that syntax resides somewhere in the left hemisphere, perhaps in something called Broca's areas. But as has been noted in a variety of ways, and is now becoming more fashionable to note, Broca's area does all kinds of stuff that involves ordering and perhaps other kinds of analytic processes, not just in language. If what we're finding is that familial handedness has this effect on lexical access in particular, it may be changing the, the result may be a really profound difference in how language is organized in FS plus people. Now, the question is, of course, are we talking in the linguistics sense about e-language, the language that's out there, or the language that is in here, so to speak? And so we might just be talking about two ways of processing a language as opposed to representing it, or we might be talking about two systems for representation. Trying to answer this, of course, requires a lot more research, especially to try to understand what aspects of the lexicon the FS plus people are really clued into. It could just be associative relations, or it could be syntactic processes and knowledge. And in many of today's linguistic models, the lexicon actually carries a great deal of the syntax. In fact, of course, in minimalist views, the syntax is a little molecule of tree building, and what differentiates one language from another is, in fact, the structure of the lexicon itself and the structure of the words. So if they are differently represented, and this linguistic model or something like it is true, then we really do have some arguments that there's a profound difference in the representation of language in these two normal groups. But we come back to this stubborn question, this belief that there really ought to be one normal, the question is, as I alluded earlier, if there are different substrates for language, what happens to I language, which is the intentional system that is the inner generator of language? It produces the extensional system, the E language. Now, this could lead to a speculation that if there are two normal ways of processing language with two different relative emphases, that there's a complementarity of constraints on E-languages at any rate. Because with these two large groups that may process language somewhat differently, they have to accommodate whatever E-language results as filtered by these two groups of language users is going to have to accommodate to what is preferable for each of those groups. And so that's a question that leads to the possibility of thinking, at any rate, that whatever it is that makes language possible isn't exactly completely determined by the particular centers or even pathways that all humans share, but rather language has certain properties that are accommodated to in the best way that fits an individual brain. And we see two large groups of individuals with some arguments that their brains are different. And that, I think, leads to quite a different way of thinking about the foundation of the neurological foundation of language than is often covertly assumed. The case is not closed. So thank you for your attention. And I'll now